So let's wrap this chapter up by visualizing a few more properties. This time we're looking at complement of sets. Let's get started. We have this universal set and we have our set A. And what's the complement of A? It's everything that's outside A. So this is our complement. Let's say we want to find the union of A and A dash. So let's say we want to find A union A dash. We take all the elements of A and add all the elements of A dash. What do we get? Well, we get all the elements inside the entire universal set. So A union A dash should be equal to the entire universal set. And that's the property. A union A dash is equal to the universal set. This is called the complement law of U. We took the union, now let's take the intersection. We have the universal set A and A dash. What's the intersection of A and A dash? Or what's common between A and A dash? By definition, there's nothing in common. So A and A dash have nothing in common. One is inside this blue line and the other one is outside this blue line. There's nothing in common. So when there's nothing in common, that set is called the empty set. So A intersection A dash is phi, the empty set. And this is called the complement law of phi. Let's say we have A dash, but we're not satisfied. We take the complement of A dash itself. So we have A dash, but we want to find A dash dash, the complement of A. What do we get? Think about it. Complement means we're taking the opposite. So when we first took the complement from A to A dash, we moved outside the blue line. We took its opposite. And now when we're taking the complement again, we'll move inside the blue line, which means we go back to the starting point, we reach A itself. So A dash dash should be equal to A. Think of it as a negative sign, the opposite. If you take the opposite's opposite, you get to the same thing. So A dash dash is equal to A. And this is called the law of double complementation. Let's look at another one. We have this empty set and we have this universal set. What is the complement of the empty set? Well, if you have nothing and you take its opposite, you get everything. So the complement of phi should be equal to the universal set. And you can do this in reverse as well. What's the opposite of everything? Well, that's nothing. So the complement of universal set should be equal to phi. And these are called the laws of empty and universal sets. Now let's move on to my favorite one. This one is called the Demorgan's law. So let's start with the universal set and have A and B as blue and green regions. You have the set A and you have set B, and together they are A union B. Okay. So the Demorgan law says that A dash intersection B dash is the same as A union B dash. Let's look at it visually. So let's start with A dash. Blue region is A and A dash means we'll move outside the blue region. Where do we go? We go in the gray zone. So this is part 1. Where else can we go? Well, we can go in this pure green zone as well. Together these two make up A dash. Now let's look at B dash. Now we want to move outside the green zone. And where do we go? Again, we go to the gray zone, or we can go to the pure blue zone. This is your B dash. Now, if you want to take the intersection of both of them, we're looking at things that are common. Pure blue and pure green are not common, but the gray zone is common in both of them. So A dash intersection B dash is actually the gray zone. And what's another way to say that? Well, the gray zone is everything that's not part of A union B, which means is the complement of A union B. And that's exactly what's written here. So A dash intersection B dash is the same as A union B dash. Demorgan's law has a second part. Here we took the intersection, but we can also take the union. A dash union B dash is equal to A intersection B dash. The signs get reversed. Let's look at this one as well. For this one, we're taking the union of everything that we have marked. We have the gray zone, we have the pure blue zone, and we have the pure green zone. And if we take the union, we'll say that we cover all three regions. But what's left? What's left is this middle region, this intersection between A and B, the part that's common between A and B. So we're saying that we'll sit outside this part, which means we're saying that we'll take the complement of this part. And what's this part? this is A intersection B. So what we're saying is this is equal to the complement of A intersection B, which means it's A intersection B dash. And that's how you visualize the Demorgan's law. And that's it. With this, we wrap up all the important properties that are covered for this topic, sets. But these are just some of the properties. You might come across some more properties, or you can even make your own properties. The key thing here is visualization. If you practice drawing these properties out, you'll never have to remember any single one of them.